This is already, we've had some great conversations, but this is definitely something where I'm going to be asking a lot of questions about your acronyms, I feel like, because there's so many flying around. So be prepared for a ton of questions.
Tommy never uses them.
Yeah.
I try not to now, but they just slip out.
When you think of traditional edge or something like that, you think of like a retail situation, right? Stores, automotive. When you start to talk about the tactical edge, how do I take this and then bring in our DoD type of framework, right? So zero trust networking, working in disconnected networks, right?
So how do you think about those things?
So secure by design. So partnering with organizations like Snook that have things like trusted compute modules, have the ability to do a secure boot, do measured boot. Another framework that we love is remote management. So the OpenBMC technology.
Does that open up another compliance issue?
It doesn't.
What makes it secured versus like
end-to-end encryption? It's also well known. The whole idea of BMC and intelligent platform management interface has been around since 2015.
Is there any last thoughts before we kind of wrap this up?
If we do have 10 more seconds, he can probably fire off like 50 more acronyms.
We're good.
It's a really easy question. I think what we're talking about is what's at the very edge.
Hey everyone, welcome to the Edge Tech Podcast. I'm David Kosloski. Today, I'm sitting here next to Tommy Scherer, who is the principal architect at Spectro Cloud. Thanks for being here, Tommy.
Absolutely. Thank you, David.
And then we've also got Mark Perry, who is the director of public sector growth, also at Spectro Cloud.
Yeah, appreciate the time today.
Yeah, thanks for being here, guys. Today, we're going to be talking about mission-ready edge computing. This is already, we've had some great conversations, but this is definitely something where I'm going to be asking a lot of questions about your acronyms, I feel like, because there's so many flying around. So be prepared for a ton of questions.
Tommy never uses them.
Yeah.
I try not to now, but they just slip out.
So I guess last time we had you guys on the show, or we had some of your colleagues, we talked about just traditional edge deployments. But I really want to touch on what is the difference between traditional or what is tactical edge deployments?
Yeah, really what we see are applications that are for mission. They have, components that are bringing in ISR feeds, so surveillance. They might be doing signals intelligence. They might have classified data. They might also require things like secure messaging for mission planning. So these tend to be more ephemeral applications. They tend to be stood up very quickly. They tend to be deployed into contested environments. Point of sale, maybe it's doing computer vision. These are constantly evolving and require kind of a unique set of requirements to allow for that continuous modernization of our federal government, our Department of War, our DoD.
Yeah. And I mean, to kind of piggyback on that. So, you bring up a good example, like traditional, right? So when you think of traditional edge or something like that, you think of like a retail situation, right? Stores, automotive. We can even encompass like oil and gas into that, right? And you do have security components that have to happen, right? You don't need access to people's data. But when you start to talk about the tactical edge, how do I take this and then bring in our DoD type of framework, right? So zero trust networking, working in disconnected networks, right? So not being able to access that cloud or have cloud sync or something like that, and still being able to access the application that Tommy's talking about. So that's really where it gets divided. And we could use edge, but when you think of a tactical scenario, you're really out there in, a contested environment. You're not around your data center. You're not around the guys that can help you with it. What can we do to package it up, make it available to run in these contested environments that, it could be like for you guys a Snook, right? The hardware and everything, being able to work in a rugged environment and incorporate it with our software where then it could run disconnected.
So when you say tactical, do you typically mean secure? Is that like the kind of the related definition, or?
That is definitely a requirement. So working within the DoD frameworks, the federal frameworks, there's many controls. They're very well documented. To be able to field software, you need to implement things like hardening. You need to have encryption. You need to have zero trust networking, so we don't trust anything blindly on the network. So all traffic is encrypted end to end. And then, finally, once you have all the parts and pieces in place, all the layers, then you can bring that mission application. And that's really what the warfighter cares about, is how do we bring new capability, whether it's offensive, defensive, cyber, whether it's the ability to fly a drone and be able to see further, whether it's able to to track people via their key fobs, do simulated red force tracking, also be able to track your blue forces, ensure that you know where everyone is on the battlefield, be able to relay that into command and control using things like team awareness kits, attack servers, being able to have improved situational awareness and be able to leverage things like cutting edge hardware. We really like the Snook, the integrated GPUs. So you can start to use some of the AI, some of that agentic tools to maybe reprocess data, more responsibly use tactical data links, which are terrible, high latency, very slow. And then also, highlight key bits of information.
You're saying a lot of things, and I want to unpack some of these. So, like tax, for instance, and like I know you said the acronym, but what of these are specifically unique to the tactical edge versus traditional? Are they all? This is all has to happen only for tactical. We would never do it for traditional.
We're seeing some overlap. Team awareness kits are beginning to be deployed still in the government, but in the civilian space. It's a common tool to share information. So we're seeing it in joint task forces. We're starting to see like drug enforcement, detectives, larger police departments share information. We're also seeing it within firefighters. So especially large scale forest fighting, we're going to bring in multiple different departments, maybe some federal, is you need a common platform to share information. That could be messaging, that could be typically laid over a map. So you know your area of operation, and then that ability to bring in additional sensor feeds. So surveillance.
Yeah, and I think so to kind of wrap that in, because again, that's why he's the principal architect, and I'm like, I do this a lot when he's talking, but to like bridge that gap, I mean, we were talking about this morning, I think a great example is like, let's use an airport, for example, right? You have different federal agencies that are going to be working within it. Also, now you're incorporating local, right? So almost taking a DoD framework where it's a joint task force that, works with Border Patrol to everybody else. These type of activities happen in an airport. And if you could we could use the scenario of saying it's a tactical edge device and put these within the airports. If something happens with these airports and Border Patrol has to show up, or FBI has to show up, or you have these interagencies that are going to be interacting, how are they connecting in? How are we sharing the surveillance with them, but then also keeping it away from other people, right? So there's a lot of scenarios where this can work. And it doesn't just have to be in these, when you think, hey, I'm out in the desert or I'm in Guam or something like that. It doesn't have to be that, but it's that scenario of how do I make what we call coalition networks, right? Multiple nations or multiple agencies accessing something. How do I make it secure, available, and also locally?
Yeah, you mentioned encryption too. I feel like that should be something that only unique to tactical. I feel like there's got to be a lot of use cases even on the private side, right?
Definitely on the private side, dealing with money, BII, ensuring that you can process payments securely. I think the federal government does a really good job of setting standards. They have a FIPS standard. We're compliant with FIPS 140 TAC 3. So it's just taking it to that next level to ensure that you're using secure ciphers. What we've gotten from the intelligence community, the NSA, CIA, is you have to operate in these environments as if your networks have already been breached. So that's the concept of zero trust. They can't blindly trust any device on the network because we feel that any network that we deploy on could already be penetrated.
Interesting. It sounds like the complications that could come with this from the federal space or tactical definitely prepare you to make, I guess if you focused on tactical first, does that mean that traditional is a lot easier to navigate?
We feel that way. Yeah. And there's a lot of overlap with the requirements with healthcare. The networks in hospitals are almost as bad as DoD networks. They're very secure. They're hard to reach out. In a lot of these environments, we have a deployment methodology that's very similar that we do within the federal government, which is air-gapped. So basically, it can't touch the internet directly. We also see it in other regulated industries like oil and gas. And we, especially when you start to look at, some of the team awareness kits, some of the secure message planning, things like matter most, where on the federal government side, the DoD side, we're using it for mission planning. On the commercial side, you're using it for incident response. So what happens if a train derails? What happens if a pipeline cracks? It's how do you get the right senior leaders in a virtual room to start making decisions and start working down a checklist.
And I mean, and again, relaying it back is, I think of even the time we were talking about, man, we were discussing a lot this morning, but I think about it even from the telecom side, right? So you have, cell sites and all the different sites that could be out in the middle of nowhere, right? Contested environments in one fashion or another, really, when you think about it, they need to be more secure. Also, if we could run some of the things we do in a data center locally, then that's also doesn't give someone an avenue to come in and infiltrate the network, right? And get out there. So, I mean, yeah, I think it does trickle over from the DoD side because that's the norm there, right? This has to happen, and I think this will lead into some of the conversation we're going to have around that CTF or certificate to field and ATO, things like that, where how do they create these stacks that then you do have the ability to deploy within these environments, right? So taking those type of requirements and then bringing it over to, the commercial enterprise side, then yeah, I mean, right out of the box for us, we're like, okay, this is going to be more secure. So yeah, you're going to be great,
I'm gonna go off script because I just have some questions around the use cases. So I understand a lot like healthcare use cases and a lot of the traditional stuff. What are the use cases that, you personally, obviously being in the military, like what were the use cases that you were like, this is where compute and edge compute really helped? Or that you even see?
Yeah, I was actually talking to somebody, I think it was at Soft Week, and we were talking about, when you would get, say, you go in somewhere and all of a sudden now we have documents and these documents have to be processed. And, what if we have the ability now, instead of taking them, putting in an envelope, they get sent to headquarters? What if that could be, we could put in, either take pictures, whatever we need to do, we could process it right there. Once it's connected, boom, it automatically ships off. Or better yet, I think to Tommy's point that he was bringing up, when you start to incorporate some of that AI and then the messaging within it, what if I had the ability to scan through those documents in real time locally? Would that have helped with responses of, hey, we know where this guy's at sooner? Like I think about it from that aspect is being able to process stuff there locally as a team quicker. And now we're going to have a quicker response, right? To the fact is, I even think about it in my time when I was in the Army, and I'm like, I think one of the things we hated the most was pulling security. What if I had the ability to set up, cameras that then locally it reports back sensor, even to the fact that it is like, hey, there's a guy walking with an AK-47, alerts a certain member of the team or whatever.
What do you mean by pulling security?
You could put so basically somebody always has to be up when you're in a contested environment, right? So just to make sure, hey, if anybody's coming, going, also keeping track of that, coming and going, what's going on. If something happens, somebody radios in and says, hey, we have a call for fire, something like that, they wake everybody up, right? But if you could automate all of that and actually have cameras set up, and even to the point if somebody does radio, hey, wake some. So I think about it like that, how it can help a team. If I need to change exfil sites or something like that, what if I had something locally that it can, preloaded with maps, everything else, and I'm like, I have these requirements that I need for exfil because it's this size, whatever, I need this type of clearing, and I can run that through, and it gives me, best option and maybe 3 more options. So, I mean, I could think of so many scenarios where that type of like tactical edge kit, would would really come in handy.
Yeah. When you bring up the example on pulling security, is that the right terminology? Yeah.
Yeah.
So when you bring that up, it makes me immediately think, if no one is watching physically, how do we trust that it's not going to get hacked? Which I think comes into the security compliance issue, which is why it's so heavily regulated. Is that fair?
I think that's absolutely fair. And I think Tommy compound on this is, we even talked about it a little bit before this started, right? If you take that approach, even with AI and how you train things, yeah, I think, again, before these ever get fielded, it has to go through that process, right? So by the time it gets there, yes. Can we ever say anything's 100%? No. Is zero trust something that we can always say, hey, there's no way we're going to get hacked? I don't think anybody could say that. But if you're doing the due diligence up front, going through these processes, by the time it gets there, it should be at a point that, hey, this is what we're fielding it for. It's gone through the processes. I feel comfortable. This is something that we could deploy.
Yeah. And I think that brings up arguably, it sounds like federal has maybe the most difficult compliance. I mean, you're talking about high risk, right? Like in this contested area, I'm going to try to use your terminology. In this contested area, we're talking about people could potentially hack a system and then put everybody at risk. And that's a really big problem. And they would want to, right? So now we're up against hardcore compliance. Is this fair?
Absolutely. Yeah.
So how do you mitigate those waters?
Right. So there's a process. Typically what you see with these systems that are fielded, it's an authority to operate. Traditional systems can take up to a year.
And ATO is the authority to operate, correct?
Authority to operate. So that's looking at everything from the hardware vendor you're choosing, ensuring that it's built in the United States, is TAA compliant, has the proper encryption levels, is free of all high and critical vulnerabilities, looking at the operating system that's being run, every piece of network that's communicating, and all the pieces that you need to do policy enforcement. And then you finally get to layer on top that mission application. And that delay in fielding these solutions, these platforms, is really hurting our speed to response. Is how do you get, things like new drone targeting software in mission? How do you get something like sensor where you're pulling security and you're more efficient? You can see further. Our thought is to accelerate that by bringing a framework, bringing the necessary components you need for compliance, and then allowing the customer, the program, to bring that final piece of, how they're going to authenticate to the platform, where they're going to operate, so setting the boundary of the network, and then finally that mission application to accelerate that approval process.
How long does this happen? You're saying accelerate the approval. What is the standard?
So, standard can be 6 months to a year by leveraging, a lot of the things in place and looking at the framework that, Kessel Run put together with Brian Kroger, with the Sentinel program put together, the Air Force program with Kyle Fox. They came up with this concept of a continuous ATO. It was built on top of common components, so hardened operating systems, leveraging a container runtime environment, Kubernetes. And kind of the way that we see Kubernetes is that's that common operating platform that you can deploy on lightweight edge devices. You can deploy it in the data center. You can deploy it in the cloud. So that allows you to have a very common platform that you know how to secure. And then in those cases, those two continuous ATOs, they leverage a stack called Big Bang from the United States Air Force Platform 1. And that comes with the necessary items you need for continuous logging and monitoring, two-factor authentication, end-to-end encryption, policy enforcement. So it allows you to inherit the vast majority of these controls. These current controls come from NIST 853.
The what, sir?
NIST. NIST 853. It's hundreds of controls. It goes down everything from password complexity
Is this something that you do on a day-to-day? You're working through all of these details, or is it a team of people?
It's a team of people, and the nice thing about government standards, they're very well documented. There's a lot of tools you can use for checklisting. Since it's well documented, your operating systems, we've worked very closely with Canonical. We also work with Red Hat. They have, the ability to reach that level of compliance, and then you start working up the stack. Our goal is to give an ATO template to our clients, to where they have to fill out as little information as possible to get these solutions fielded, and then ensure that even if an ATO-in-a-Box, a simply NUC device, a SNUC, got into the hands of our adversary, they would just have a really sweet piece of silicon. They'd have a really nice gaming PC, but they're never going to be able to extract data.
In your role, like where does it fall in that are you just kind of like understanding the risk and communicating it? I guess like with the difference here, it sounds like yours is very like following protocol and making sure, like where does yours kind of come in?
Whatever Tommy tells me to do. Yeah, as you can tell. So taking that and then kind of spreading the word of what that means, right? So, I can say it's a shameless plug or, just kind of promote what we put together, right? Is, Tommy and I talk about it, and I went to him, I said, hey, I want to build out something that's an actual solution, right? That would meet a need. If you had to pick one today, Tommy, what would it be? He goes, ATO. I was like, I really like that. So then I take that and then put it into with removing a lot of those acronyms or something like that, just an easy readable of this is what you can accomplish, right? So when he talks about this continuous ATO and everything, I don't want to say this exact number, but, to translate that, and that's kind of what my position is to translate that into what does that actually mean? Where would it fit within certain, sectors or whatever?
So most people that are purchasing these solutions, in a sense, they're not going to be in the weeds like you are, in a sense. Like, so it does have to be still fashioned in a way that is understandable.
Correct. I mean, because yes, what he's saying, the ones that are really in there and doing it, or even part of it, right? They understand it, right? I can always say, I'll go in places a lot of times. I'd use myself as an example, and people go, because I was an engineer for the past 15 years, and people are like, oh, you were a cyber guy. I was like, no, I was an Army infantry guy. And they're like, how does that correlate? I was like, I just really like tech. So I got into it, right? So I could walk in a place, I can understand the nomenclatures or some of the acronyms, but there's certain things that I'm like, I've never worked outside of it, so I still don't understand, right? But I could still have a hand in part of it, that if I understood enough where it fits into what I'm looking for, I can then pass it on. Because that's the hardest part when you work with any large organization, DoD, for example. You want to try to get to the right people that know what you're talking about, but sometimes you got to say things like, he mentioned Kubernetes. There's time that I would take that and I go, we have a platform that can allow you to do this, this, and this, right? Yes, there's people within that understand Kubernetes that will go right away, go, oh, wait, he's talking about Kubernetes. I want to listen.
Yeah.
But if I tell him, hey, what if I gave you a platform and we did this with Snook that from, day 0 and day 1, 80% compliance for your ATO right out of the box.
When you say 80%, let's unpack that. So it doesn't have to be at 100% compliance to be able to actually.
It does, and I'm glad you mentioned that. Go ahead, Tommy.
It does, and we require our clients to bring a few pieces. So you have to define the boundary where it's going to be operated. So that's like a network boundary, whether it's going to be air gapped, whether you're going to be accessing it through VPN. You need to bring something for identity management. And, a lot of the programs use different things. Some are cloud-based, some are local. In the case of this, we've also done some work with like YubiKeys. So you physically stick a USB key in there, you boot the device, you remove the key, and then as soon as that device is powered off, you're never going to be able to get any of the data off. So having some flexibility there. And then finally, what they actually want to bring is the mission application. So they're going to have to ensure that the mission application they're using is compliant.
So, and I think that's a great time. We mentioned it before, and, there were two things to say, right? A certificate to field and an ATO. So when I think of that, so a certificate field is usually fashioned towards, I need to get this one piece of software approved, right? Or a mission application, which means that's a faster response time because that's it, right? An ATO, or that authorization to operate, is fashioned towards a full stack, right? Multiple like complex layers that I have to get authorized for me to be able to go work in these contested environments or in these mission environments. So what if we gave you the ability that we could get you almost there, and all you've got to do is, maybe if you don't have it yet, is get a certificate to field for that piece of software mission applications to put within that box. That speeds up that process dramatically.
So essentially, just want to make sure I'm understanding. We're getting 80% of the way, but we're asking the quote unquote customer, which is the federal space, is saying you have to implement these practices though to get you to 100% compliance.
Yes.
Are you typically creating those processes for them, or do they have it already? Are you giving suggestions? Like, is there a consulting area there? Or?
You can give suggestions on what to use, but these are, he talked about the NIST framework and everything. These are a framework that's already solidified within the government that are non-negotiables, that this has to happen for you to be able to have a full 100% ATO approval for you to work in a field environment. So they have to do it. They do have the leeway of choosing how they accomplish that. So
Sure.
a lot of the times the stuff he's talking about, they already have in their environment.
Exactly.
So
you're utilizing what already exists. And the reason I asked too about where you, definitely was not fact checking your job here, but the reason I was asking is because
It's cool. I'm just going to get fired.
I'm curious on the element of in explaining or selling the idea of ATO-in-a-Box, like what have you. It sounds like there's this compliance checking system that's happening, but also that the people that are buying it may not be aware of it. It just happens behind the scenes naturally, or how does it? I guess like what's that process? It sounds like because you're explaining it, but you're not saying Kubernetes, you're saying a platform. So there's got to be a disconnect here where the people who are making these decisions to say we need this in the field don't actually understand the compliance.
So I think the beauty of it is, and we went back and forth on this, like, as soon as you said ATO-in-a-Box, I was like, that needs to be the title. Because kind of what you're talking about, right? Who understands it? Everybody understands the ATO part. Because it doesn't matter what is happening within that environment, that contest environment, it has to be ATO'd. So whoever you are, you do know that. Now there's going to be the ones that work in different areas of it that are like, when you say Kubernetes, they're going to go, that doesn't apply to me. Okay, well, you still have to use Mattermost. Yes. Okay, cool. That actual run on it. I don't need to tell you that it's Kubernetes. But by the way, what if I gave you a platform to run your mission applications in a contested environment, offline, incorporating all the zero trust security you need? They're going to go, yeah, I need that. I work for DoD. I need that. Then that's where, of course, like the Tommies and everybody come in and they go, okay, now let me expand on that. But the ATO-in-a-Box is the ultimate. Everybody knows what we're talking about.
And when you're looking at, where the software has previously been deployed, it's typically been in secure clouds. So either top secret or secret cloud regions, or on-premise, on physical servers, well secured in the data center. The unique challenges come when you're bringing this data outside of those secure environments. And there's additional things you have to think about, is things like encryption on the devices, self-encrypting drives. How do you communicate with the device? How do you update the device? How do you ensure that you can bring a new mission application and not break it? If you're looking at, traditional edge or retail, it's a bummer if you have to roll your truck, but it's not the end of the world. If you're in a contested environment, you're going to send 4 guys in, an AFSOC group, Air Force Special Operations, to fast rope in and fix this device or recover this device if it wasn't encrypted.
So how are you thinking about those things?
So secure by design. So partnering with organizations like Snook that have things like trusted compute modules, have the ability to do a secure boot, do measured boot. Another framework that we love is one that Intel helped write, was the secure edge native architecture. Snook has taken it a step further and opened up the platform to other processor types. We really like the accelerators with the AMD cards, and then further enhancing the platform with that ability to pull in remote management. So the OpenBMC technology, where you can remotely log into the device, re-image the device, get a remote keyboard and mouse to do that all remotely. Yeah,
I'm glad you mentioned, because that's one of the things I was going to call out, was that BMC side is, so you made the, like, what does everybody understand is that, most work within a data center and they have that ability. So if all of a sudden that person's out in the field, why would I change that? So having the ability to have that look exactly like the data center, again, that will help negate issues that could happen within these environments that have to be stood up very quickly, broke down very quickly, moved, whatever. So that was a big one for me. I was like, oh, that's
The BMC was.
yeah.
I mean, and definitely don't want to play devil's advocate for the place that I work, but bear with me. Does that open up another compliance issue or another opportunity for security risk?
It doesn't, because it's well defined. It's a well-defined API. It's well secured, and it's
What makes it secured versus like
end-to-end encryption. So everything's communicated over HTML5. It's all encrypted with SSL. You can bring your own private key infrastructure to it. It's also, well known. The whole idea of BMC and intelligent platform management interface has been around since 2015. So the federal government's comfortable with it. They know how to secure it. They know how to, operate with it. The unique thing we see with, OpenBMC is it decoupled a lot of that functionality from the traditional silicon manufacturers. So as you look at, kind of what Intel brought to market with AMT, it was very opinionated. You must use, these Intel CPUs, which I feel like when you're looking at, again, these tactical kits, one, they need to be small, they need to be lightweight, and they need to be power efficient. So when you're looking at the density that Snook brings to the table with, the AMD processors that have, higher frequency, higher core count, and then as you guys begin to expand into ARM CPUs, we start to see a lot more value, a lot more computing power per watt.
Yeah.
Yeah, I'm thinking about it now, and it's crazy to think that, we were talking about an R720, right? And you're thinking about a 2U big server, full length. This is a full rack server.
24 sticks of memory,
Yeah.
processors, all the IO cards. What's sitting in that box is more powerful.
Yeah.
That's crazy.
And so now when you think about the power that we could hand the warfighter at the edge and be able to accomplish that, and then now we lead it back to that ATO discussion, and we give you something that is hardened, that has that continuous ATO ability. Now, like, you're talking about something extremely powerful.
Wait, and go on the ATO side, because I know without bringing it out here, the device is in a Pelican case. So what is the reason for that?
Well, I've already dropped it twice at the airport.
But there's a reason for this, right? Like what is would it be deployed that way?
No, I mean, that's the beauty of it too. We were talking about even oh man, I feel like I should work at Snook, because now I'm like, we were talking about how it's fanless, right? So yeah, I could throw this in a backpack. I could throw this in a, but when I think about it, when, I used to be in Humvees and everything, you have everything secured, tied down, everything's boxed, stuff like that. If I have that in a box ready to go, boom, pull it out, has everything, slam it on the hood, plug it into the Humvee and go. Yes.
It's definitely very military to say that you're slamming it on the hood versus setting it nicely.
No, you don't set anything, or at least not me.
And for our friends in the Navy, it floats.
Yes. There we go.
That's great. What do you think are going to be the biggest challenges for what we're talking about in the future? Is it going to be ATO? Is it going to speed up, do you think, with the CATO? I think you mentioned, what are the gaps that we're not talking about?
Yeah. So, the other person you work with when you do an ATO is an authorizing official. So as authorizing officials see this technology more and more, they start to see cloud native platforms that have a lot of the controls and that ability to do the same thing that you're doing in the cloud on the edge. You can begin extending that secure cloud computing architecture to the edge device, being able to assume a lot of those same controls. So that's going to, help the authorizing officials, make the case that, yes, we can operationalize the software at the edge. We're starting to see new frameworks from the federal government, but they realize this process to field technology is slow. But we, looked at it is adhering to the existing standard, the existing, 300 and something controls that you need to put in place. And then as the government evolves to adopt these solutions faster, we'll be ready. But being able to fit into those existing frameworks.
Yeah. And I think, I really like that question, because I think, the onus is really on us, within the industry if we want to work and, play in this field and everything else, is ATO is not going to go away, because now we could talk about it. Yeah, I think we mentioned AI. What happens when we start to do that incorporate? What does that mean to the ATO-in-a-Box, right? How do we keep up with that and make sure we're still compliant? We're still offering something that's going to meet the needs, from the power to everything, right? And then to Tommy's point, if I'm so used to running it here, give them the flexibility. I could use AWS Wicker, for example, right? We augment it extremely well for then allowing them to take something that they're used to from a data center. And when I say data center, this is what people are using on base or, in these connected campuses or something like that, right? And be able to do something that's very similar, just take it out to the edge, right? But do it securely.
And allow, specifically with Wicker, we're allowing that command and control to go from cloud to edge, and then allow the cloud to communicate back.
From the AI perspective, we're talking about deploying models at the edge, right? And when you even mentioned the automation of viewing somebody with the AK-47, I feel like the observation is that this is all moving very fast. And even though everyone's acknowledging that this process is slower than it should be, what stands in the way, I guess, of the Fed moving at a rate that stays ahead of this curve?
I think a lot of it comes from platform. Is if we can get a platform out there that's flexible, that is, compliant, they can begin to iterate on that mission software faster. So we can bring them, the necessary layers they need to get a piece of silicon in the field that's secure enough. They can begin bringing those models. And what we found with, AI being deployed in the field is it's what's good today, might be, out of date in 2 weeks. Or there might be updated firmware and a camera. And now you need a new model because it's focusing different. That ability to do that continuous modernization out to the edge. And that's one of the reasons why Kubernetes is, by leveraging containers, you can really use it as an ideal platform to deliver payloads of software.
Yeah, and that is a great point, and kind of piggybacks on what I said earlier about being able to take, say, using Wicker as an example. But yeah, how do we modernize what maybe they're doing now, right? And give them, again, a platform that's already, authorized, has the compliance, meets the need that, and we didn't really touch on it. What about the legacy stuff, right? This is maybe where we could get into foundationally how, Spectro Cloud works, but, running AI within a containerized environment is a lot different than trying to say, I'm going to set this up within virtual machines, right? But there's still virtual machines that need to run within these environments to support some legacy applications that happen within DoD. Now, when I say that, back to your point earlier, everybody at DoD right now, I'm talking to you, you know what I'm talking about with these legacy applications, right? But being able to take them, give them a platform where not only can they modernize and at the pace that they need to, but then support those legacy applications that have to be there. So
in the way these applications were typically, deployed by global systems integrators, the ones that build airframes, the one that's build missiles, they would physically deliver a ruggedized laptop. You would get one laptop per capability. So now what we're seeking to do is build a platform that can have multiple capabilities, and then also that ability to change the mission profile is, an example of, might send a field out to do defensive cyber operations. They're just listening. They're just looking for digital fingerprints, looking for attacks. And they might find something interesting. And they might be able to take that attack and go offensive and be able to use that same piece of gear, those same group of operators without, bringing in another piece of equipment.
This sounds maybe, one, it sounds more economical. Is it? Like being able to bring I feel like an edge device that's that small versus a ruggedized laptop for each functionality, that sounds really expensive. Is it some more economical solution?
Absolutely. And, that's one of the reasons why, when we're looking at silicon manufacturers, looking at Snook is, you guys are about a tenth the price of some of the other ruggedized stuff.
Interesting.
So that allows us to, deploy more compute, put more edge kits out there, derive those contracts to get more compute into the hands of our warfighters.
Oh, absolutely. And I think we've definitely reached a point where, I just feel like, and maybe you feel like this too, when we said tactical kits 10 years ago, you better have a suitcase, you better have a big backpack when you're talking about a tactical type of thing. I mean, it's almost like I have a mobile data center. That was the size of it. That's what we were architecting at the time. And now when I look at it, I'm staring at it right now. I'm like, it's hard to fathom what I can do now and the size of that. And yeah.
You didn't just need the data center that you're packing in. You also needed a diesel generator.
Yeah, that is true.
So now you're talking about, huge heat signature, tons of sound. Now you're looking at something that's, not drawing much more power than a cell phone.
Yeah.
They can run off batteries. They can run off solar.
Yeah. So I think companies that, which I feel we do real well is try to look at, what is kind of the future? How do we modernize and everything? And even from the Snook aspect is just that. How do we prepare for the future, give them what they need. And I think you guys are on the right track with that, right? And being able to accommodate what the future could bring, that rapid pace. We could say, I mean, I could start talking conspiracy, theory here in WW3 and everything, but there's a commonality of where everybody thinks that's going to kick off, right? And that's not a place where anybody has a ton of troops or a station. How do we get there quickly, effectively, operate under compliance, and then also work with, sister nations that we, are already doing stuff with, but we have to meet up in a general area, right? And I think the quickest way we could do that, and I always think about it for the fact, I want to help the warfighter. Hey, we're Americans, we're taxpayers. Like, to your point, if I can go out there, give them a solution that's compliant, save the cost of it, I feel like I'm doing a better job, right?
Keeps them more safe too.
Yeah.
It's huge. We keep referencing this box and the sales pitch on Snuck. It definitely is surprising and grateful. Seriously,
Hope you brought your trap book.
Yeah. Thank you guys so much. I mean, we've got a video coming up, obviously, about the ATO-in-a-Box, which we're in demo, and hopefully some more content coming out in collaboration with you guys. So we're really thankful for the opportunity. I think it's a really exciting topic, and I'd love to continue to talk more about it. Unfortunately, I'm getting the flag on time, so I do think we rented out this space. We got to get moving. But is there any last thoughts before we kind of wrap this up?
I mean,
I think we covered a lot.
Yeah.
We're excited about the partnership. We're excited about the hardware. We're excited where the organization is going with Snook, adopting new processor technologies, ARM, and, driving that power, that low power threshold.
Yeah. I mean, I can, again, double down on that. Yeah, I appreciate the great relationship. And I think that's what it takes to work in that space, is coming together and working well together. And if we do have 10 more seconds, he can probably fire off like 50 more acronyms.
We're good. We're good. I appreciate it. I do one call out that I do think was interesting so far in the last day here was that you mentioned lower thermal, and my brain, even as a marketer, doesn't think about that. But you're 100, like when you said it, I was like, oh, that clicks. Like, yeah, this is actually a big deal. On top of cost savings, it is safer in a lot of different areas. And so I just think it's really cool what everyone's trying to work on personally. And I think this kind of space is just super interesting. So I hope to continue to have more conversations about it. So thanks, guys, Tommy, for showing up and being on the show today. It means a lot. And I'm excited to learn more about ATO here in a minute.
I also appreciate it.
Thank you all so much for listening to Edge Tech Podcast. Again, I'm David Kosloski. See you later.